Today we have seen the introduction of geology, engineering geology subject. Then we have also seen the branches of engineering geology. Then we have also seen the history of engineering geology. uh, Then what is the scope of engineering geology, what how this engineering the knowledge of engineering geology is applicable to the physical life. Then we have seen the formation of our planets, our solar planets system. Then regarding this planet, we have also seen the what are the compositions and density of these planets and rate of rotation of these planets. Then we have also discussed about the origin of earth, what are the theories which supports the represents the theory how the earth has been formed, and there are different hypotheses which support the these given theories. And then we have also studied the method which we are used to calculate the age of the earth. Then and there are different methods like organic evaluation, sedimentation rate, then salinity of sea water, then rate of cooling. Okay, and then we have also seen the understanding the interior of earth, how the interior of earth has been measured, has been identified based on this for passage of P wave and S waves. There are different zones in the earth interior, which were crust, mantle, outer core and inner core. Then we have discussed in more detail way of this crust, mantle zone, outer core zone and inner core zone. And then today we will see the basic theory of earth structure. Okay, first of all we see the continental drift. What is meant by continental drift? Okay, so the continental drift is the slow movement of continents away from each other during the history of earth. It is the slow movement of the continents. Okay, so this theory of continental drift was invented by Alfred Wegener. Alfred Wegener has invented the theory of continental drift in 1910. And about he said that about 200 million years ago, the continents were one. Okay, so about 200 million year ago there was only one continent, okay, on our earth, okay, which were called as supercontinental. Okay, and the remaining part were covered by the ocean. This part is called as panthalasso. Okay, and this continent part, one continent part is called as Pangaea. Okay, then Albert Wegener, that scientist have proposed that Albert Wegener proposed that the whole continent were break into the whole continents were break into small species. Okay, which were called as smaller continents. Okay, which were called as smaller continents, and these are separated or drifted together. Okay, separated and drifted together under the action of differential gravitational force. Okay, due to the action of differential gravitational force, these continents are separated and drifted together. Okay, and like the floating pieces of woods. Okay, like how the wood pieces has been floated on the water, so like that floating of wood pieces, these continents were drifted. Okay, and that time this theory, which was given by the Albert Wegener, which was not accepted over 40 years. Around 40 years this theory was not accepted, and then after in 1950s and 1960s some evidence were found which supports this theory, and this theory received the supports in 1950 1960, and this theory were in 1950 and 1960, and then we'll see what is plate tectonics. Okay, so there are, as we know, there are different plates in the earth crust. Okay, so in the plate tectonics is scientific theory explains how the major landforms. Okay, this is the scientific theory which explains how the land forms and the mountain was created. How this plate tectonics theory explains the how the land has been formed and mountains have been created. Okay, and there are also the some faults has been created into this plate tectonics. Okay, so as we know, when two plates where meet each other under the action of impact of two plates or the meeting of two plates, some graduation happens at this portion where the two plates has been intersects each other, and that portion mountain has been formed. Okay, that portion mountain form. And when this one plate separate each other under the action of differential gravitational force, like pull force is applied on one plates, and then due to that these plates get separated into two pieces. Okay, due to that this fault form. Okay, this is the action of separation of plates, and this is the effect of meeting of two plates. Okay, then the plate tectonics are the huge moving slabs. Okay, these slabs having the thickness of 150 to 200 kilometer, sorry, to 200 kilometer. Okay, 150 to 200 kilometer. That makes that this plate tectonics makes then earth outer layer, and there were 7 major plates. Okay, so no, total number of plates were 7. Okay, so we'll see these 7 plate from largest to smallest in size. Okay, first of all, North American plate. Okay, second one is Eurasian plate. Okay, third one is African plate. This is African plate. Fourth one is Antarctic plate. Okay, so this bottom plate is Antarctic plate. Fifth one is Indo-Australian plate. This one is Indo-Australian plate. And sixth one is South American plate. This is South American plate. And last one is Indian plate. Okay, Indian plate. Okay, so these plates are around, sorry, previously I said it is 150 200 kilometer. It is now 100 kilometer to 150 kilometer thickness. Okay, these plates are 100 to 150 kilometer thick and carried both continental and ocean crust with them. Okay, these are continuous. These plates are continuous in motion with respect to each other. These plates were continuous in motion with respect to each other. Okay, now what is meant by plate boundaries? Okay, so all seismicity or volcanicity and tectonicity activities become localized. Okay, at the point where all the seismicity, volcanicity and tectonicity at what we call as the moving or motion of these plates were localized or neutralized at that level, at that place we called it as plate boundaries. Okay, so all seismicity, volcanicity and tectonicity activity become localized or neutralized at plate margins. This plate margins is called as plate boundaries. Okay, and these plate margins are classified into 3 groups based on their relative motions. Okay, so based on the relative motion, these plate boundaries are classified into 3 groups. First one is divergent boundary, second one is convergent boundary, and third one is transform fault boundaries. Okay, so we'll see one by one. So first of all, divergent points. When plate gets separated from one point, there is a divergence, and this is divergent boundary. Separation, see, this is separation rate is up to 1 centimeter to 6 centimeter per year. The rate of separation of this plate is 1 centimeter to 6 centimeter per year. Okay, now this is come in divergent boundary. Now if this plate meets each other, there is a convergent. Okay, so this is comes in convergent boundaries. And when this plate transform, means laterally shifting of plate from one place to another place, this is called as transform fault boundaries. Okay, so today we have seen the continental drift. What is meant by continental drift? Okay, then what is supercontinents, then who proposed this theory of continental drift? Okay, then what is meant by plate tectonics? Okay, so how the mountains has been formed, how the fault has been formed. Then we have also seen the total continents on the earth, and then the thickness of this continent is 100 to 150 kilometer. Then we have also seen the plate boundaries. Okay, so these are divergent boundary, convergent boundary, and transfer fault boundary. Okay, in next lecture we'll see the physical geology. Okay, thank you.